Hello friends, in this video of today we are going to deal impact of jet in a stationary vertical plane. So let's get started. So first of all we have to draw a pipe. Then after, this is our pipe. Then we have to draw our nozzle. Okay, now we have to draw a plate in front of the nozzle. Okay, vertical plate. Let's shade it as question said, or as the topic said, it is a stationary plate. Let's fix it, and this is the symbol which represents the plate is fixed or stationary. So the jet will come out of it from here. Okay, the dia of jet is represented by small d, and the velocity of the jet is represented by v1. Okay, so due to the diameter remains the same everywhere, our average velocity will be same, that is v1. Okay, so suppose what is the area? Here the area is being used by the fluid, this section, it is like this, and the area will be A equals to pi by 4 d square. Now jet makes an angle of 90 degree with the stationary plate, so automatically if the jet strikes or hit the plate, so at that point velocity will be 0 in x direction after strike. So let's make it like this way. After striking or after hitting, the jet will be deflected at an angle of 90 degree. Let's make it more interesting. Here, after jet strike the plate, if there is no loss, means the plate is very smooth, it will not have any energy loss. So the velocity of jet traveling will be same after the deflection, and it moves upward with the same velocity, that is v1. So the velocity is same, so we write here v1 because there is same velocity, there is no loss. Okay, one thing more, if the jet strikes the plate, one thing we have left, if the jet strikes or hit the plate, at that point velocity will be 0. At this point, suppose this is v2, and after strike this v2 will be 0. Okay, so we have to find the force which is exerted by the jet to the plane. We have to find the force exerted by the jet on the plate. So it is determined by Newton's second law of motion, that is impulse momentum equation. So by Newton's second law, we may write F means force equals to mass into acceleration. So whatever the force which is to be exerted by the jet in x direction to the plate, because the jet moves in the x direction, so we may write Fx, because it is in x direction, we are considering x direction, m into a into x, because acceleration will be in x direction. So we write acceleration in this form also, change in velocity with respect to time. It means v2 minus v1 upon t2 minus t1. After putting this equation, we get fx equals to m into dv upon dt. Okay, if you want to find the force exerted by the jet to the plate, we have to take the initial velocity minus final velocity. Okay, here we find the force exerted by jet on the plate. So we take initial velocity minus final velocity. So our equation becomes F equals to m into v1 minus v2 upon dt. So if we multiply by m, we get, if we multiply the above equation, we get we know that momentum means momentum equals to mass into velocity. Okay, and we also know that if velocity increases, if the value of velocity is more and value of mass is less, the momentum will be increased. If the velocity is less and mass is greater, momentum will be less. And if the velocity will be less and mass will be also be less, then momentum will also be less. If velocity is more and mass is less, then momentum will also increased. Okay, so we may write Fx from the above equation. We can say that Fx or force in x direction will be written in this form also: initial momentum minus final momentum by time taken. We may also write this. Okay, so we can say that the force exerted by the jet on the plate will be, Fx will be upon dt. Okay, here m will be the mass of fluid. Now we know that density equals to mass upon volume, and mass will be density into volume. Okay, again we know that volume is equal to area into height. Okay, so mass will be rho into area into height. If we put in the equation, we get Fx equals to m rho into a into h upon dt, v1 minus v2. Okay, we know that displacement with respect to time is velocity, so the equation becomes rho a v1 minus v2, and we know that v2 equals to 0. As the jet strikes the plate, the velocity of jet at that point will be 0. So the equation becomes Fx equals to, this is our force exerted by the jet on the plate in x direction, will be rho a v1 square. If we want to find the force exerted by the plate on the jet, we will write v2 minus v1. Okay, here rho a v1, this is Fx will be rho a v1, v2 will be 0 and v1 will be v1, then Fx will be minus rho a v1 square. Okay, so these are the two equations. What are the difference between them? These are the two equations. Here we find the force which is exerted by the jet. Here we find the force which is exerted by the jet on the plate, and in this equation we find the force exerted by the plate on the jet. Okay, so this is for today. Now if you have any queries, then you can write in the comments below, and if you are new to our channel, please do not forget to subscribe to our channel. Please press the bell icon so that you can get the latest update from time to time. I am Mohammad Akhtar signing off. Thank you.